Hello everyone, welcome back to the channel. Today let's discuss our topic, that is gluconeogenesis. Now, coming to the topic, first we have to understand the basic idea about gluconeogenesis. Rather directly going to the reactions and mugging up the reactions, right? First, try to learn what is gluconeogenesis. Gluconeogenesis is a process where our body produces glucose from non-carbohydrate sources. Okay, it is a process where our body produces glucose from non-carbohydrates sources. Why this gluconeogenesis process is necessary? It is necessary because when there are no glycogen stores, the gluconeogenesis is the only process in our body which produces the glucose. Okay, and it supplies the glucose to the organs which need glucose for their normal functioning. This gluconeogenesis process it also helps in clearing the metabolic products like the lactate, glycerol, and propionyl CoA to supply glucose to the essential organs like brain, RBC, renal medulla, testis, etc. And it also clears the metabolic products like lactate, glycerol, propionyl CoA. The gluconeogenesis process it occurs in cytoplasm and mitochondria also. 60 to 90% of the gluconeogenesis occurs in liver and 10 to 40% of the gluconeogenesis occurs in kidney. Coming to the proper definition of gluconeogenesis, it is defined as synthesis of new glucose from non-carbohydrate precursors. The examples of these non-carbohydrate precursors, non-carbohydrate precursor. The examples of the non-carbohydrate precursors, they include pyruvate, lactate, glucogenic amino acids, and there are some intermediates of TCA, that is TCA cycle intermediates. We also have glycerol along with propionyl CoA. These are the non-carbohydrate precursors. As we have learned few points regarding the gluconeogenesis process, now let's learn about the reaction for the production of glucose from the first non-carbohydrate precursor, that is pyruvate. Production of glucose from pyruvate, it occurs through the gluconeogenesis process, which includes the glycolysis steps along with the TCA cycle steps. Let's start with the production of glucose from pyruvate. Glucose production from pyruvate. We know that the production of glucose from pyruvate it includes both the steps of the glycolysis and the TCA. So first start with the glycolysis. We know that the starting material is glucose in glycolysis. This glucose it gets converted into glucose 6-phosphate and then fructose 6-phosphate, and then it gets converted into fructose 1,6 bisphosphate. Now, after a few intermediate steps, we have phosphoenol pyruvate, and ultimately the phosphoenol pyruvate it gets converted into pyruvate. The gluconeogenesis process it takes place both in cytoplasm and mitochondria, right? Hence, this pyruvate it gets transported into the mitochondria. Let's draw a box representing the mitochondria. Assume this as the mitochondria, and this entire portion it is the cytoplasm. Now, pyruvate present in the mitochondria enters the TCA cycle, and from there the TCA cycle occurs. We have citrate in between along with malate and oxaloacetate. After this, the malate present in the mitochondria gets transported back into the cytoplasm and it gets converted into oxaloacetate. Here in TCA, the malate is getting converted into oxaloacetate. Same occurs in the cytoplasm also. The malate gets converted into oxaloacetate. And now, this oxaloacetate it gives rise to phosphoenol pyruvate. This is the basic skeletal structure of the entire glucose production through gluconeogenesis process. Okay. Now, coming to the enzymes used in the reactions, let's start with the basic glycolysis process. Now, we have glucose to glucose 6-phosphate. This occurs through hexokinase. Fructose 6-phosphate gets converted into fructose 1,6 bisphosphate in presence of the enzyme phosphofructokinase 1. Now, we have the production of pyruvate in presence of pyruvate kinase enzyme. There are 4 irreversible reactions. I will represent the irreversible reactions. I will represent the 4 irreversible reactions with the double-lined arrow. The pyruvate gets converted into the oxaloacetate. This oxaloacetate gets converted into malate. This is the irreversible reaction. Okay. This is the first irreversible reaction occurring in mitochondria. And we have our second irreversible reaction taking place in the cytoplasm. The third irreversible reaction it occurs in the cytoplasm. And we have our fourth irreversible reaction here, ultimately leading to the production of glucose. The conversion between glucose 6-phosphate and fructose 6-phosphate it is reversible. Okay. Coming to the enzymes required in the irreversible reactions, the conversion of pyruvate to the oxaloacetate it occurs in presence of pyruvate carboxylase. And the second reaction it occurs in the presence of phosphoenol pyruvate carboxykinase. The third one it occurs in presence of fructose 1,6 bisphosphatase. And the fourth reaction it requires glucose 6 phosphatase. Here the first reaction it requires ATP and the second reaction it requires GTP. Let's look at the first irreversible reaction. Okay. In the first irreversible reaction, we have pyruvate getting converted into the oxaloacetate. it requires ATP. Okay, it requires ATP as we have discussed earlier, and inorganic phosphate is released. Now, it also requires cofactor, that is biotin. As of now, remember this reaction. I will add one more component later. Coming to the second reaction, this we have oxaloacetate, right? This oxalate acetate is present in mitochondria, and we have another oxaloacetate. Oxaloacetate. This is cytoplasmic component. Now, this oxaloacetate it gets converted into phosphoenol pyruvate. Same. It requires energy. Here, GTP is utilized. It gets converted into the GDP and PI. Here, the enzyme required is pyruvate carboxylase. The enzyme here used is phosphoenol pyruvate carboxykinase. No, I said I will add one more component, right? Just add CO2 here. Add CO2 here and remove CO2 here. That's it. Here, fructose 1,6 bisphosphate. It gets converted into the fructose 6-phosphate. And in fourth reaction, glucose 6-phosphate gets converted into glucose. Now, see. The enzyme used in the third reaction is fructose 1,6 bisphosphatase, and the enzyme here is glucose 6 phosphatase. In the third reaction and fourth reaction, we have utilization of H2O, which gets converted into inorganic phosphate. H2O is inorganic phosphate. See, here we have used pyruvate as the substrate, and we have produced glucose as the product. Coming to the energy consumption, we know that for one glucose, two pyruvate molecules are required, right? For one glucose, two pyruvate molecules are required. Hence, there is a utilization of 6 ATP.